So in this video, we are going to see what duck typing really means in practice by going through an example. So in the vector class that we study in operator overloading, we define a dunder add method, and which is used for adding a vector with something else, right? So in that something else is in this other parameter, and when we did this, we wanted to make sure that the other is also another vector, and if it's not another vector, then we raise a type error, right? So this works fine, and I actually have the code here, and here I instantiate two vectors, and we're able to add vector A and B together. However, when we add the vector A with a number, it should complain. So, and indeed it does. So C is okay, but here it complains because we raise a type error here to say, we want the other to be the vector. Now, as we just said about duck typing, because the fact that Python doesn't have the type information until the time that the code is executed, and because of duck typing, it's not a very Pythonic thing to check for type using is instance. So if we don't check for type, then what can we check for? Well, if we look at what the code really needs, it needs this other parameter to have two attributes, the dot x and the dot y, right? So as long as other has these two attributes, this code should work very happily. So then what we can do instead of checking for type is that it checks the other, that it has the x and the y attribute using the built-in function has attribute. So I actually type it out here already. So instead of doing this, we can do this, which checks for the x and y attribute. Okay, and if other doesn't have the right attribute x and y's, then we can raise the type error as before. So if we run this, we will have the same result as before, but now instead of checking for type, we check for the existence of attribute or what it can do or what it has. So using has attribute and then raise the type error if that check fails is our first attempt at using duck typing in the dunder add method. Now, that is not the only approach we can take though. So if we look at this carefully, what we do here is we make sure it's okay before we do the addition. So that is kind of check before we leap approach, right? But we can also do something different, and that is we can just do it and then, or we can just jump, but we'll try to catch ourselves if we fall. Okay, so that we can do with a try and except block. So instead of checking before we jump, we just do it. However, we put this in a try except block, and now if other does not have a x or y attribute, then it would raise an attribute error. And when the attribute error is raised, then we can say, okay, well, the other doesn't have an x and y, so it's a type error. We raise that to report it. So if we run this, and again, this code would be good as far as a plus b goes. Both of them are vector, but when it gets to a plus 3, it would complain that the other should have x and y. So this is our second attempt at duck typing, and in this attempt, we don't even check the attribute, the existence of the attribute using has attribute. We just try it, and if there's a problem, then we handle the problem. Now, let's think a little more carefully about what happened here. That we are handling an attribute error. But what do we do when we see that attribute error, which is an exception? Well, we just raise another exception. Now, sure enough, this exception is a slightly different exception. It's a type error instead of an attribute error. But to the client code that calls the Thunder add method, does it really make that much of a difference that it's a type error instead of an attribute error? And if it does not, then we can just totally forego of handling the attribute error and just let it be raised as it is. So by that, I mean, instead of doing the whole try and accept thing, we will just do the addition. And we don't even try to handle the attribute error that is raised, that can potentially be raised. So let's run this. And what happens is, again, up to a plus b, that's okay because they're both vectors. And now when we get to a plus 3, we're going to see an exception. Now, so this is an attribute error, and it's telling us that, hey, this int object has no attribute x. Well, and if we look at this, then we can indeed see, 3, which is the int object is talking about, well, it does not have an attribute x. So this error, in some sense, it has, it has no less information than the type error that we raised in the previous approach. But when you compare the code of this Thunder add method with the previous definition, then this one is really a lot cleaner because it has fewer number of lines and it has no branches or try and accept block. As a matter of fact, if you compare this last definition with the definition that we started with, that actually checks for the type. Again, the latest definition is cleaner code, and as far as the client code is concerned, when when an operand of the wrong type is passed to it, it gets some sort of exception in all of these approaches. So as a summary of what we just talked about, and for this Thunder add method, especially in terms of what we do when there's a invalid operand in the other parameter. So the first one is the traditional type checking using if instance and raise an error if it's the wrong type. Now, the next 3 approaches are all duck typing approaches. The first one is, let's check the attribute using has attribute and raise the type error if we don't have the expected attributes. The second one is, let's just do it, but we'll put our code in the try and accept block, and then if there's an exception with regard to some of these attributes, then we raise another exception to report the error. And the final approach is we'll just do it and let the whatever exception there is to be raised. The last 3 approaches, they all use the idea of duck typing. The first one doesn't because it explicitly checks for the type, but all of them, all 4 of them, they behave similarly from the perspective of the client code, because when the other parameter is invalid, because they all raise some sort of exceptions when that's the case.